Okay, so here is the video for the first practice exam. So I'm just going to run through it and refer to the answer keys as well, guys, which are linked to in our calendar. So in order to do this first one, I have to do long division. 14x squared plus 11x minus 5, 2x plus 1. Okay, so 2x times what makes this? 7x. Okay, then you're gonna subtract. So 11 minus 7. Okay, so this is 4x, bring down the minus 5. This times what makes that? And you subtract again. And then this is negative 7. So plus negative 7 over 2x plus 1. Okay. Now I split up this integral. So the first part is going to be the 7x plus 2. And then the second part, I'll pull out the 7. It's going to be minus 7. And I'm going to leave a space for a denominator, because I'm going to need to do f prime over f. I need to use that formula here. So I might have to write something in that denominator. Okay. So now, for this part, this is just going to be a regular antiderivative. This one here, I've got to use f prime over f. So you let f be the denominator, 2x plus 1. Then f prime is 2. So I need the top to be 2. So I'm going to multiply the top by 2, and then I also have to divide by 2, which I will do outside. All right, now I'm ready for the antiderivatives. So this is 7 halves x squared plus 2x minus 7 halves natural log absolute value of that plus c. Okay, so there's number 1. Number 2, find the area enclosed by the curves without using Math 9. So this means that we're going to have to use the fundamental theorem of calculus. Now to find the area between two curves, you're either going to do the integral of top minus bottom or the integral of right minus left. But we can't use top minus bottom, because if you look here, a vertical line here would intersect this graph 2 times. All right, the vertical line or the horizontal line can only intersect each graph once, and that's how you know whether you're going to use vertical or horizontal, things. So I can't use top minus bottom. I've got to use right minus left. So this is the right function, this is the left function. And when you're doing right minus left, you need everything in terms of y, which means you've got to solve for x. All right, so solving for x, this is 4y minus 2y squared. Solving for x here, y squared minus 5y. All right, so these are the forms that we're going to be using for the right and left function. Okay, so we're going to do integral. Now, since everything is in terms of y here, we're going to go from the lowest y, which is 0, to the highest y, which is 3, and then right minus left. So 4y minus 2y squared dy. Okay, now I'm going to simplify inside. I'll do a little aside. 4y, 2y squared. Right, negative 3y squared plus 9y. Okay, now you're ready to do the fundamental theorem of calculus, which is this. I put the antiderivative inside, so this is negative y cubed plus 9 halves y squared. All right, then you're going to plug in 3. So this is negative 3 to the third minus, and then you're going to plug in 0, which just gives you 0. And you end up in the end with 27 over 2. Okay. So that is the first page. Here is the second page. Okay, we're going to find the area bounded by these functions. Now this one here, guys, is a line, so that's how you know that this is f of x. It's the linear one. And then the other one, this function is g of x, right there, because that's not the line. Okay, we're going to need to do top minus bottom, and you've got to find, guys, these intersection points here. So we're going to be doing top minus bottom for this interval, okay, for this interval here, and then we'll have to change the top and the bottom switch here. So we're going to need 2 integrals in order to do this. Let me grab a calculator. I'm also going to turn the lights on. All right, so lights are on. Excuse me. All right, I got to find the intersection points. So I'm going to graph 2x minus 5, x cubed minus x squared minus 7x plus 3. So I'm going to graph those. Okay, I got these 3 intersection points I got to find. This one is a little bit low, so I'll just go to my window and I'll make my y min like negative 20 or something. Okay, now I've got to find all 3 of these intersection points, and then I'm going to store their x coordinates. Because we're doing top minus bottom, everything is in terms of x, so we don't need the y coordinates of these points. We only need their x coordinates. So I go second calc, intersect. I move close to this, enter, enter, enter. Okay, and so then I'm going to go back to my home screen. I'm going to hit x, and then I'm going to store it as A. If you don't know the buttons I'm pressing, we've been doing this, guys. So if you don't know the buttons I'm pressing, ask someone or ask me. Okay, but this is kind of old news at this point, how to store. So right here, this x value is negative 2.9575 ... and I stored that as A. Okay, now I got to find this one. So I go back to my graph, and I go close to this, enter, enter, enter. Then I go to the home screen, I hit X, and I will store this as B. So for this one, X equals 0.8784 ... That's B. I'm doing ... because I'm not rounding. And then this one I need. Okay, hit X, store as C. X equals 3.07911 ... That's C. Okay. So now I may use Math 9. So I've just got to write the integrals and then I can use Math 9. So our first integral is going to go from A to B. The top function is G. So x cubed minus x squared minus 7x plus 3 minus the bottom function is that, plus the integral from B to C, and then they just switch. So the top is the line minus the bottom is that one. Okay. And then, guys, I'm not going to go through the whole thing, but I'm just going to like show you a little bit. So you're going to go math 9, and then you're going to type in from A to B, and then you put in the function there, dx plus math 9 from B to, whoopsie, stop. Okay, yeah, from B to C, and then you type in the function there. Okay, so into these blank spaces, guys, you know, you're just typing those. And then you hit enter, and you will get 47.517. Okay. Now the third page. So there's only going to be one number 4, but they could be like either of these two. All right, so this is from K-11. Let the region R be the area enclosed by the function x to the third minus 1, the horizontal line y equals -4, and the vertical lines x equals 0 and x equals 2. All right, so they're describing this shaded region here. If the region R, this shaded region, is the base of a solid such that each cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in the region R, find the volume of the solid. So guys, when they say each cross-section perpendicular to the x-axis, that means we're using vertical slices. Okay, so if you were to take this solid shape and slice through it vertically, the slices that came out are going to be isosceles right triangles with one leg in the region. All right, so let's draw, oh yeah, so the way that you do this, all right, since we're using vertical slices, the volume is going to be the integral from 0 to 2. All right, this is all in terms of x. Leftmost x is 0, rightmost x is 2. And then we need the area of a cross section with respect to x dx. All right, now here's a little aside. The area of a cross section. All right, so let's just do one cross section. This is an isosceles right triangle. So this is one leg. One of the legs is there, and then it goes like this and that, but it's coming up like out of the page, okay? So it looks like this. And isosceles means that those legs are the same. Now for a regular triangle, that's the area, 1/2 base times height. But for an isosceles right triangle, it's 1/2 base times base because the base and height are the same. So 1/2 base squared. So 1/2, guys, to get the base, you've got to do top minus bottom because this is the base. Okay, so in this case, the top function is f, x cubed minus 1, minus the bottom function is right here. The bottom function is -4. So minus -4, and then you're squaring that whole thing. All right, so this is from 0 to 2, and then x cubed, -1 minus -4 is -1 plus 4, that's 3. X cubed plus 3, oh shoot, 1/2 x cubed plus 3 squared dx. And then you type that in your calculator with math 9. Oh. Yep, you type that in your calculator with math 9. Actually, I did it wrong in the answer key that I'm looking at. I said that this was 0 in the answer key. I have to fix that. All right, so math 9. So 0 to 1/2 x cubed plus 3 squared. Okay, I'll have to fix that on the answer key. 30.143. Okay, so number 4 could be something like that. Or number 4 could be something like this. So let the region R, this shaded region, be the area enclosed by this function, the horizontal line y equals 2, and the x-axis, the y-axis, I mean. Find the volume of the solid generated when the region R is revolved about the line y equals 5, which is right here. Okay, that's y is 5. This one is y is 2. All right, and then we may use a calculator. So with volume, since we're revolving around a horizontal axis, let's look at what the shape is going to be like. All right, so I'm going to reflect the region over this line that we are rotating around. So this point goes, all right, and then this point is like here. So here. All right, so I guess it looks not great. All right, so it looks something like that when I reflect. But this is actually like a 3D shape. So when you're doing this rotation, this is going to be a washer, not a disc. Okay, so it's going to be like a donut, every cross section. Okay, so just imagine like, and it's going to look like a cylinder almost, but it's going to be going out, you know, like this, I guess. Yeah. And this is the shape that we get for each cross section, for each slice. And since we're revolving around a horizontal line, the slices are going to be vertical slices. Vertical slices mean that your volume formula is in terms of x. Now you look at the original region here. The leftmost x is 0 for the region that we're rotating, and the rightmost x is 2. And then we need the area in terms of x dx. Okay. Now, the way that this works, guys, all right, so this is, so top minus bottom. All right, top, bottom, and then a second bottom. That's for our radii. Okay, so the area of a washer is pi big R squared minus little r squared. So big R is this entire big radius, okay, all the way from the center of the washer to the end of the washer. That's big R. Little r is the inner radius. That's the length from the middle of the washer all the way to the end of the empty part. Okay, so that would be little r right there. So this is pi, and then we're going to do top minus bottom squared minus top minus bottom squared. And the bottom is going to be different each time. This first bottom, or never mind, I won't even say anymore. All right, pi. Okay, the top, so I'm going to do the big one. So from here to here. So top is 5, bottom is radical 2x. 5 minus radical 2x squared. Minus, this time top is 5 and the bottom is 2. 5 minus 2 squared. All right, so that's the area, and now I'm ready to put it in here. I could take this pi, and I could pull it out front of the integral. Integral from 0 to 2. And then this is 5 minus radical 2x squared minus, all right, this ends up just being 9. And then you type it into your calculator with math 9, and you get 29.322. Okay, so there's that page. Next page We've just got 2 more pages. Okay, so now number 5, you're going to do a slope field. Okay, something called a slope field. So consider the differential equation that is right there. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. So we've got 12 points that we got to find little slopes for. So xy, dy, dx. xy, dy, dx. So 1, 2, 3, 4, 5, 6, 7, 8. All right, whatever. Okay, I'm using the x value -1, 1, 2, 3, 4 times. 1, -1, -1, -1. Then I'm using the x value 0 4 times. Then I'm using the x value 1 4 times. Okay. Now, so for these x values, -1, 0, and 1, the y values repeat. This y is 0, this y is 1, this y is 2, this y is 3, and then it keeps going. So 0, 1, 2, 3 for the y's. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Okay, and now for dy dx, I am plugging the x's and y's into here. Okay. Now I'm going to plug -1 in for x every time, and then it's to the 4th power. So we're just going to get positive 1s. And then for here, I'm doing y -2. So I'm taking each y value and subtracting 2 from it. So 0 minus 2 is -2. -2, -2, -2. So this is -2, -1, 0, and 1. Now this section is going to be really easy because you're plugging in 0 for all of these x's, and 0 times anything is 0. So all of these actually are just going to be 0. And then this section, all of the x's are +1. When you raise them to the 4th power, you still get +1. And then in here, I'm just taking the y coordinate and subtracting 2 from it every time. So actually, this is repeating. -2, -1, 0, 1. Okay, now I'm going to go through and do all of the 0 slopes. Okay, because the 0 slopes just have little horizontal lines. So for all of these points, the slopes at those points are all 0, so I just do these little horizontal lines there. I've got 2 more 0 slopes though. At -1, 2, the slope is 0, and at +1, 2, the slope is 0. So -1, 2, and +1, 2. So there I have more horizontal slopes. Okay, now for the slopes that are not 0, I'm going to use like little dots to try to estimate the steepness of each slope. So for this first point, at -1, 0, the slope is -2. So I'm going to go down 2, right 1 with little dots. So down 2 and right 1. Then at -1, 1, I have a slope of -1, so I got to go down 1, right 1. And then at -1, 3, I have a slope of 1, so I go up 1, right 1. And then you go back and you fill them in. So here I go from my last dot through the given dot. And it will give you like a pretty nice, like a pretty accurate, like approximate steepness. Okay, now I'm going to do these slopes on these points. And they're actually kind of repeating. So I go down 2, right 1, down 1, right 1, up 1, right 1. Okay, guys, there it is. That's the slope field. Okay, we've got one more page. The last two problems on the exam are going to be solving differential equations. So this one, given the differential equation there, find the particular solution with this initial condition. So this initial condition is telling us that when x is -3, y is -6. All right, you always start out by cross multiplying. So y dy equals x squared minus 6 dx. So step one, cross multiply. Then you ask yourself, are the x's and y's separated? Are these all y's? Yes. Are these all x's? Yes. So once the x's and y's are separated, you take the integral of both sides. So this is 1/2 y squared equals 1/3 x to the third minus 6x plus c. Now this initial condition is what's going to allow us to solve for c. So I'm putting -3 in for x and -6 in for y. So that's going to be 1/2 -6 squared, 1/3 -3. Okay. Okay, this ends up being, I'm just going to skip a little bit. On our answer keys, guys, there's more detailed work, but this ends up just being 9 plus c. So you get that c is 9. So then I plug that c into here. So 1/2 y squared equals 1/3 x cubed minus 6x plus 9. And now you've got to solve for y. So I'm going to get rid of the 1/2 by dividing everything by 1/2, which is the same as multiplying everything by 2. So this is y squared equals 2/3 x cubed. Okay. Then to get rid of the square, you take the square root of both sides. And when you take the square root of both sides, you always need a plus or minus. And then we'll figure out which it actually is. Okay, now the plus or minus. You look back at the initial condition. So since f of -3 equals -6, guys, if we need to be getting negative outputs, if our outputs need to be negative, that means that it's going to be the negative choice. So y is equal to negative all of that. Okay, here's the last one. What is the particular solution to this differential equation with that initial condition? So you're going to cross multiply first. So when I do that, I get dy equals cosine of x, 1 plus 3y dx. Then you ask yourself, do I only have y's over here? Yes. Do I only have x's over here? No. This 1 plus 3y, that needs to be over here. So you just divide by it, 1 plus 3y dy. Okay. Are these only y's? Yes. Are these only x's? Yes. So now you're ready to do the integral of both sides. Now this one here, we're going to need f prime over f. So, I'm going to need f prime over f, so maybe I'll put like a 1 over, and I'll leave a blank, because if I put something up here, I'm going to have to divide by it outside. So for the f prime over f, if f is 1 plus 3y, then f prime is 3. So I need the top to be 3, which means I would divide by 3 on the outside. Okay, so this is 1/3 natural log absolute value of this. The antiderivative of cosine is sine. Now you've got to find c. And you do that with this initial condition. This is telling you that if x is pi over 2, y is 0. So this is a third natural log of 1 sine of pi over 2 plus c. Guys, natural log of 1 is 0. And then sine of pi over 2, use a unit circle. Pi over 2 makes you land up there, and the coordinates are 0, 1. Sine is the y coordinate. So that's 1. So you end up with 0 equals 1 plus c. So c is negative 1. And then you can plug this c back in up there. So it's a third natural log equals sine of x minus 1. Now we need to solve for y. Okay. So I got to get rid of the 1/3, so I'm going to divide everything by a third, which means multiplying everything by 3. So maybe I'll go up here. So this is natural log absolute value of this equals 3 sine of x minus 3. Now, how do you cancel a natural log? By putting a base of e on both sides. So when you put a base of e on both sides, those cancel, and we get absolute value of 1 plus 3y equals e to that. Now, if you're going to solve for y, you need to drop the absolute values. So you can drop the absolute values if you put a plus or minus there. Okay. Now, you've got to ask yourself, is it the plus, is it the positive, or the negative? Okay, and so you've got to use the initial condition. All right, so we know when x is pi over 2, y is 0. So this gives me 1 equals plus or minus e to the 0. Okay, I want 1 equals 1. So it's going to be, so 1 equals the positive 1. So positive. So I got 1 plus 3y equals the positive 1. And then I can subtract 1 from both sides and then divide both sides by 3. So y is e minus 1 all over 3. Okay, guys, that is it.